Hi everyone, so for today's video, we will be looking at chapter 1, physical measurements and units, but we will focus on scalar and vector quantities, more on vector resolution. So go to page 5 of your notes, tutorial notes. Okay, so here we will be discussing the second learning outcome, resolve vector into two perpendicular components, x and y axis. So you have learned in the lecture that you can represent the vector by using an arrow. So the length of the arrow showing the magnitude of the vector, the direction pointing where the arrow pointing is the direction of the vector. Let's say I have two vectors A and B. So from here we can say that vector A is longer than vector B. So the magnitude of A is bigger than the magnitude of vector B. Okay, so focus on resolving vector. Let's look at this example. So we have a particle S experience a force of 100 Newton. So for this example, our force is the vector because force have direction. So the magnitude of the force is 100 Newton. So the length of the arrow is 100. Determine the x component and y component of the force. Okay. Remember, to resolve a vector, we have to follow a few steps written here. Steps to resolve a vector, or why we want to resolve the vector, because we want to determine x and y component of the vector. So the first step to determine the x and y component is draw x and y axis on the vector. So for this one, let's draw the axis. So this is y axis and this is x axis. Okay, next we have to determine the angle to be used to resolve the vector. So when we want to resolve the vector, we have to use angle less than 90 degree. So after this, you will know why we need that angle. So here we have 210 degrees. Remember, find an angle close to the vector here, less than 90 degree. Okay, so look at this vector. It is on this quadrant. So you can use here as the angle, or you can use this one as your angle to resolve the vector. If you want to use the red one, it is 30 degree, or the blue one is 60 degree. Okay, I choose one only. Here, I will be using this angle. The third step is draw the triangle where the vectors are. So from this diagram, you have two possible triangles. The first one is this one, or the second one is the blue one. Depends on which angle you are using. You can take the red angle or the red triangle or the blue triangle. If you want to use the blue triangle, you need to use this one, but I will choose the red triangle. So let's draw the red triangle. So here is my 30 degree. Here I know it is 100. Okay, so you have learned in maths that if you want to find this length, you can use sine theta equals to opposite over hypotenuse, because this one is opposite to your angle. So sine 30 equals to opposite over 100. So your opposite is 100 sine 30. And if you want to find this one, the adjacent to the angle, we can use cos. Cos theta equals to adjacent over hypotenuse. So we have cos 30 equals to adjacent over 100, and you will know that the length of your adjacent is 100 cos 30. So what you want to find in these questions is x component and y component of the force. So where is the force? Okay, let's write it below here. the force is going this way, and we have here as your angle. X component of the force is here, because this is the quadrant where the force are on x-axis, so this is Fx. So y-axis is here, this is Fy, because from this diagram, this one, we know that for this quadrant, x-axis is here, y-axis is here. So what we do is we bring this to here. So this is your Fy, and this is Fx. So from the additional notes, we just apply what we have learned in additional notes. We can see that Fx is equals to adjacent length, and Fy is equals to opposite length. So to find this one, Fx, we can use cos 30 equals to adjacent, which is Fx, over 100, the hypotenuse or the length of the force. So rearrange Fx or component x of the force equals to 100 cos 30. So you will get your x component of the force is, just calculate by using your calculator, 100 cos 30. So you will get, make sure your calculator in degree mode, because 30 degree, so you will get 86.60 Newton because of the force. And for Fy, because y component is here on the opposite to the angle, we will use sine 30 equals to opposite Fy over 100. Rearrange, we will get Fy equals to 100 sine 30. Press your calculator, 100 sine 30 is 50. So you will get 50 Newton. Okay, so because f is a vector, so we must include the direction for the vector. So let's write it down over here. So this is vector f. For vector f, x component, so when you look at in your diagram below over here, your Fx, x component of your force, is going to the left, so it will be negative over here, so it will be negative 86.60 Newton. And for your Fy, it goes downwards, so Fy, y component of your force, is negative 50 Newton. So remember, your component x and y of a vector should include negative sign if it goes downwards or to the left. But if you have a vector, let's say a new vector over here, maybe over here, so if it involves this quadrant, your Fx will be to the right, your Fy will be downwards. So for this vector, Fx is positive, Fy is negative. Let's say you have another vector over here. This will involve this quadrant. For this quadrant, your Fx is to the right, your Fy is upwards, so both are positive. And lastly, maybe your vector over here, so this quadrant, your Fx to the left, so negative, your Fy upwards, positive. It depends on your vector where it plays on the axis. Okay, so remember the negative sign. Without the negative sign, you will get a wrong answer. You may try another one. You may try with this angle 60 degree, and you will end up getting the same answer. Okay, that's all. Thank you.